Hi students, all of you welcome. Welcome to Suneel Engineering Academy. I am Sunil Kumar Bandaru. Students, in this Transformers through topic wise MCQ series, we have already completed 4 sessions. It is the 5th one. If you want previous, just click on the playlist. You can find out the previous sessions. Let us start the session. All these questions we have already completed. I think today we are going to start losses based questions. Types of transformers also completed. Yes, now losses based questions. Let us start the session, guys. Coming to the first question in this losses, a 20 kVA transformer has iron losses of 1500 watt and full load copper losses of 2500 watt. The maximum efficiency of the transformer will occur whenever the total loss is dash. Whenever the total loss is dash. We know very well the condition for maximum efficiency. What is the condition for maximum efficiency? Whenever the variable loss is equal to constant losses. Variable loss is equal to constant losses. Okay, so that means we have to match these variable losses with the constant losses. Then we will get efficiency is maximum. Okay, so variable losses are nothing but we can say copper losses. So whenever we can say the copper loss is equal to, I mean full load copper losses. Loss is equal to iron losses. Then we are getting maximum efficiency. Okay, so they are asking total losses at maximum efficiency. That is copper loss plus iron losses. Okay, so copper loss is nothing but these are also equal to iron loss plus already iron loss are there. 2 into iron losses. That is 2 into iron losses are 1500. So we can give the answer as 3000. Okay, so no need to do all this in the examination. Simple method is nothing but to get the maximum efficiency, the total losses are nothing but 2 into iron losses. Directly 2 into 1500, 3000. Okay. Here, some of the students maybe do the mistake that whenever they assume iron loss is equal to copper loss, then what will happen? Iron losses will become 2500. Then copper loss will be 25. Iron loss will be 25. Then 2500. That means you will get the answer 5000, which is wrong. Okay. So only whenever variable loss is equal to constant losses, then maximum efficiency we will get. Okay. Not constant loss is equal to variable losses. Okay. So just remember 2 into iron losses. That is directly you can get answer within 2 seconds. A transformer has maximum efficiency at full load when iron losses are 800 watts, copper losses at half of the load is dash. Copper losses at half of the load is dash. We know the formula, copper losses at x of full load is equal to, at x of full load is equal to x square into full load copper loss. Okay, x square into full load copper loss. So here at maximum efficiency, we know full load copper loss is equal to iron loss now. So they have given iron losses are 800. So full load copper losses are 800 and x they have given half of the load. So that is half square into full load copper losses are 800. That is 1 by 4 into 800, that is nothing but 200. So the answer is option D, clear. Okay, so just you have to multiply with the x square. Whatever the value they have given, just we have to multiply with x square. Half load means 1 by 2 whole square. 1 by 3 load means 1 by 3 whole square. 1 by 4 means 1 by 4 whole square, like that. Okay. If copper loss of transformer at 7 by 8 of the full load is 4900 watts, then its full load copper loss. Here they are asking full load copper loss. Just now I have given the formula. Copper loss at X of full load is equal to X square times into full load copper losses. Okay. So if here they are asking full load copper loss, this value, then you have to send this one to this side. Okay. Full load copper loss is equal to X of the full load. So X is nothing but they have given 7 by 8. 7 by 8 of the full load is 4900 by X square. X square means 7 by 8 whole square. That is 4900 into 64 by 49. 100, that is 6400 watts. So the answer is option C. Okay, so the answer is option C. Coming to the next question, guys. A transformer is working at full load and its efficiency is also maximum, at which iron losses is the 1000 watts. Then copper losses at half of the load. Already we have done this type of problem. Copper loss at any of the load is equal to that X square times of the full load copper loss. X square times of full load copper loss. Okay, so at maximum efficiency, full load copper loss is equal to iron losses. So iron losses they have given 1000. So full load copper losses you are getting 1000. That is X square. Half load they are giving now. Half square into 1000. That is 250. Okay, so here just I am giving the steps. No need to do all the steps in the examination. Okay, so you have to be practice a lot. Why? Because these questions are very important. So you have to give the answer within 10 seconds, maximum 10 seconds. Okay, so here they have given maximum efficiency. To maximum efficiency, iron losses are 1000 means copper losses are also 1000. Okay, at any of the load they are asking that load square into that value. So half load means half square into 1000. That is 1000 by 4, 250. Okay, so without pen we can give the answer. In a single phase transformer, the copper loss at full load is 600 watt at half of the load. Here directly they are asking full load is 600, half of the full load. So half square into 600, that is equal to 150. Correct? Yes, correct. So the answer is option E. Coming to the next question. The iron losses in a 100 kVA transformer is 1 kilowatt and full load copper losses are 2 kilowatt. Then maximum efficiency occurs at which load? Which load means at X. We know the formula. At X of the load, X is equal to root of iron losses by full load copper losses. Okay, here iron losses they have given 1 kilowatt, copper losses they have given 1 by 2, that is 1 by root 2. 1 by root 2. So at this load, 1 by root 2 means 0.707 of the load. So full load they have given 100 kilowatt means then at which load? 100 into 0.707, that is 70.7 of the load. So maximum efficiency will be occurs at 70.7 of the load. Okay. So this formula is very important. X is equal to root of iron losses by full load copper. Coming to the next one. A transformer has a core loss of 64 watt and copper losses of 144 watts when it is carrying 20% overload current. The load at which the transformer will be operated at the maximum efficiency. This is also a very simple question. In the previous, they have given at full excitation, here over excitation. Okay. So that whatever the load, that is overload or underload, core core loss are nothing but iron loss. These are constant. Why? Because these are constant losses, may not depend upon the load. And 20% overload means 1.2 times. So at 1.2 times of the load, the copper losses will be 144. 2 times of load, then copper losses will be 144. Then full load, what about the full load copper losses? We know full load copper losses is equal to, we know the formula. Already we have discussed here. But any of the load is equal to x square into full load copper losses. Here, copper losses at x of the load is equal to x square into full load copper loss. If you want full load copper losses, we have to divide it by x square. So here also, if you want to get full load copper losses, we have to divide copper losses at 1.2 of load by that 1.2 whole square. So at 1.2, 144 given, 1.44, that is equal to 100. So at full load you are getting 100 watts is the copper loss. So if you are getting this one, then at which the load at which the transformer will operate maximum efficiency, the load at which is nothing but x root of iron loss by copper loss is full load of iron loss 64 only, copper losses at full load 100 watts. Okay, so that means you will get 8 by 10, so that is nothing but 0.8, 80%. So the answer is option C. Okay, it is a very easy question, don't feel it is a difficult. At 1.2 of the load, they have given copper losses and iron losses. Whatever the load, core losses, I mean iron losses are constant. Okay, so we have to take those are 64 only. Copper losses will be vary with respect to the load current. Why? Because copper losses are nothing but I square R losses. As current varies, I square R varies. Okay, so at 1.2 times of the load, they have given this value means at 1 times, I mean full load means 1 time. At 1 times, what is the losses? So as current decreases, automatically losses will be also decreases. So we have to divide it with 1.2 whole square. So you will get 100 watts. So whenever you are having both core loss and the copper losses, then simply you can get x is the root of iron losses by full load copper losses. So you are getting 80%. Okay. Coming to the next question. In a transformer, if the iron losses and copper losses are 40 watts and 50 watts respectively, then at what fraction of the load? That means x. The efficiency will be maximum. Yes. Now we have calculated x is equal to root of iron losses by full load copper losses. So iron losses they have given 40, full load copper losses 50. Here so many students will do the mistake. Okay. So root 40 by 50, just multiply with the 2, root 80 by 100. 80 means almost 9 square. 9 square is equal to 81. Na? So approximately 9 square, that means 0.9 you will get. So 0.9 means answer is option D. Whenever we see this 40 by 50 or 80 by 100, you will get, we feel the answer is 0.8. Okay. So that is 0.9 or 0.89. So the answer is option D. Okay. Okay, students, we will discuss the remaining questions in the next session. If you have not subscribed the channel, please click on subscribe and also click on like button, and also please share this information to all your friends. Okay, encourage me with your likes, comments and sharing. Thank you so much, guys.